let's get into it. So sprint 1, due week 4 Friday. That's going to go quickly. You have a fair amount of work to do between now and the end of week 4. You can read this stuff about what the sprint's aiming to achieve, sort of related to the learning outcomes. Essentially, what you need to do is firstly write a proposal saying this is what we as a team are going to do. This is what we're going to do, and as a high-level plan. Then you'll need your high-level architecture and design. Then you'll need to actually plan the project itself using Jira and go through all that process, which you're pretty familiar with from 2021. Then you'll need to actually develop the service and test it, and then you'll need to deploy it in the dev environment. So Fethi mentioned before, in most systems you have development, test, staging, and production, or some variation on those. Production is the one that's facing customers. Development is the sort of sandbox environment where you can deploy services and maybe they're used internally and use something that's called dog fooding, which is where a company uses its own software to test it. So you'll just need to deploy to dev, because in sprint 2 we'll be deploying to test and all the way through to production. And then in week 5 you'll do very similar to the Shark Tank pitches from last year. You'll do a demo or die presentation, which is essentially just a pitch saying this is our idea, this is our architecture, and pitching your engineering proposal. So what needs to go in the proposal? Before that, though, you will need to submit this by the end of week 2. This isn't a hard deadline. This is allowing you to get feedback on your design so that you can go and iterate on it and improve it as a formative assessment. And it also allows, allows for feedback, and then you can actually improve the proposal itself because you'll be submitting that back. So the first thing you need to do is pick a data source. We talked about this yesterday. There's a bunch of different data sources you can choose from: disease, finance, weather, news. You can find your own data source if you like, if that's something you're interested in. Once you've picked a data source, you will need to, from there, figure out what you want your service to do. And this is where you come up with the business value. You put your design 2000 hats on and say, okay, well, what are we aiming to achieve from a product point of view? Now, we said in the spec that most, sorry, yeah, go. You should do. I realized I haven't put it on Web CMS, but if you log into Confluence or if you log into Atlassian, you should have access. I'll put it up on Web CMS later today. Probably right after this, actually. So where was I? That's right. So we don't. This ecosystem is all new because it's the first time we've run this course. So we don't have any data in the system currently. So most of you will be building import services, which will take data from some external source, right? Like might be web scraping, might be some API, and that will be importing data into the ecosystem. You don't have to do that necessarily. And what you'll do in this part of your engineering proposal is say, like, here's our idea. Now, you can build whatever you want. Insofar as you could, like, if you say, okay, we're going to build this, and another group also says we're going to build the exact same thing, we're going to both make an import service for disease events, that's completely fine. However, you will get marks for having a service that gives unique business value, so not the same as everyone else, and you will also get marks for communicating with other teams. Because you all know how to work in a team. Hopefully, you'll be doing that through the next 10 weeks. But we're going to take that to the next level in this course. You'll be communicating between teams. There'll be an extent to which you can do that on the forum. You can talk to each other on the forum. You can talk to each other offline as well. You can obviously talk in person. So there's going to be a lot of communication going on.
Just want to add one thing. So when you pick a data source, the data source may have lots of data. So you pick just the attributes that you think are important. So two of you might choose the same data source, but one of you might just pick the location as an attribute. Another one might pick something different. So it's possible for people to go to different data sources and pick different attributes. That will make two different services, because these attributes may be used in different ways in different applications. And also, when you go to a data source, don't pick everything. So you may go to a website and just grab one or two very important attributes and discard the rest. So don't feel obliged that your service is, because you need an event. Timestamp is the most important. An event has happened about this, and this event is this, and you can discard the rest. So yeah, that's just to talk about the design of the service. That particular event and this particular attribute
Thanks, Lily. So try and provide unique business value. You will get marks for communicating with other teams. Yes, Peter.
So there's no like course mandated.
Nope. Yep, it's for you to figure out. It's all up to you. What I would recommend is talk to other groups in your class and try and get some consistency across your class. That way you can talk to each other, you know, like if you're in the same time slot each week and get a bit of a chance to talk then. And you obviously know each other and have some proximity. Yeah.
So in terms of uniqueness and business value, is that going to be marked across the cohort or marked across?
Both. So your mentor will assess your class as a whole, and then we'll do standardization across the cohort.
Don't come initially or at the end, because getting an attribute or a particular event that you think is important may not seem important initially, but when you do your application, it's more important. Value may come later rather than. But in building and planning the service, mentioned, these are the sort of things we can.
You also need to think about, as part of this inter-team communication, about the interoperability of your services. So all the stuff we talked about with data interchange, you know, how is Team A's microservice going to talk to Team B's microservice? And is there choreography? Is there orchestration? You'll need to figure all that out yourselves. You can, oh, that's right. I'm also going to create a page where you can paste a link to your engineering proposal, and so other teams can come and view your proposal and say, okay, this is their architecture, and you can leave a comment and say, hey, you know, we're doing this thing, let's, you know, make some interoperability. So you get a lot of scope for collaboration here. So in your product requirements, you need to come up with user stories and acceptance criteria. You've done that plenty of times at this point. It's not about technical detail here. This is all, what is the product trying to achieve? What is the service trying to achieve? Here's more information about import services. The next stage is to come up with your software architecture. This is the thing we've just been talking about, whether you want a containerized microservice or a Lambda microservice. You may also want to think about other technologies. I've listed a bunch here: SNS, SQS, Kafka, Elasticsearch, caches. Don't feel obliged, don't feel like you have to include these things. You may want to if you think they'll improve the quality of your design. If you just decide, you know, maybe like you have 4 teams that are doing something similar, and one team will go, okay, we're going to manage the Kafka. And so your component is that Kafka event stream and maybe a service that does some management and orchestration of that. There's lots of cool technology to experiment with though, and just focus on building an MVP for this sprint. And later when we get to sprint 3, you'll get the chance to go back and iterate and improve the design of the software as a whole. The next thing you'll need to do is come up with a stack. This is very similar to 2021. You need to decide, you know, if we're going to build a database, what do we need to code that in? What language will we use to build the backend if you're building an API? We'll talk about containers next week, but there'll also be a container layer, and you'll need to do that with Docker. You should also think about the services layer or the dependencies layer, and that might be third-party APIs that you're importing or scraping data from. That might be other team services that you're depending on, as we've just talked about. You also need to consider cost of resources. We're probably going to give you a budget at some point. We're still figuring that stuff out, so just bear with us. Once you define the architecture, the next stage is to define the interface. As I said before, we're going to have a lecture on GraphQL and gRPC next week. You can, if you really want, you can build a REST API, but I'll say it up front, you won't get as many marks as if you didn't build a REST API. Most stuff we're pretty relaxed about which tool you use, but for this one, you've done REST in 1531, you've done it in 2021, you've probably done it in other contexts as well. So we want you to get a bit more exposure to modern software technologies. And then there's also the fact that REST is kind of going a bit out of fashion, and that these two, you can use something else if you want as well. But yeah, GraphQL and gRPC are becoming the more dominant ways of data interchange. So you need to do that and document it all in Swagger, which you've learned before. You need to make a couple of sequence diagrams, which again, done before, should be pretty easy. Now the next one, this is interesting. Measures of success. So when it comes to us assessing your projects, it's difficult because you're all going to be building slightly different things. And we're going to apply a level of standardization across markers. We'll put in assurances and checks in place to make sure that everything is fair. But how we're going to do the marking is through you. And the way companies come up with, you know, they say, okay, here's this project. We need to figure out what success looks like. We need to come up with some metrics. They do that through, they call them KPIs or OKRs, objectives and key results. The way you guys are going to do it is through marks. You're going to say, this is what a pass looks like, this is what a credit looks like, this is what a distinction looks like, this is what a high distinction looks like. And that will allow you to keep your work tractable. You'll be able to understand where you're at and measure your own performance, and then your mentor will use that to mark you for your breadth and depth of implementation. You will obviously need to get these criteria approved. You'll need to discuss and go back and forth with them on your with your mentor on them. And it will be the case that a high distinction is very much a stretch goal, and pass is your sort of basic MVP. And we'll make sure the mentors understand the kind of standardization of the criteria across different groups. Does that make sense to everyone? We want you to define what success looks like, and you to measure yourselves in that regard. Okay, the next part that needs to go in the engineering overview is constraint management. We're going to talk about theory of constraints in a second, so that will inform what you put here. Then you need to talk about the risks, the things that can go wrong in the project. Again, lecture on that from Hayden next week. You can use that theory to inform this section. Now, I've also included a list of non-functional requirements, which is good as a checklist of all the things that you just kind of need to have in your head when you're designing your service. Things like performance, things like security, which we've talked about, reliability, safety, maintainability. These are things that we'll assess and we'll kind of check them off ourselves. So you need to make sure that some stuff you don't have to worry about to a sprint too, but you just kind of go through these and make sure, does my design accommodate for all these non-functional requirements? Because they're all important. Okay, that's the proposal. All right, project management is the same as what you've done before. You need to use Jira to split up your tasks, allocate them to people, create a backlog, and put story points and priorities on everything. You should allocate some team roles, get yourself team leader, product manager, delivery manager. If you need a refresher, here's last year's slides on Scrum. We also expect that you do the Scrum communications. That's stand up 3 times a week, sprint planning meeting, and a sprint retro at the end. And then you should also have meeting minutes. A lot of these, we're not going to sort of mark these super extensively. It'll be, did you have meeting minutes? Did you do stand-ups? Yes or no? So just make sure you're checking those boxes and going through those processes. When it comes to actually building your piece of software, you'll undoubtedly do some sort of detailed design. That might be UML, that might be ER diagrams. Just chuck it in a compliments page to show us that you've been going through that process. The next one is infrastructure as code. So what you'll be doing is creating services in AWS. And there's multiple ways to do that. Some ways are through the console where you click a bunch of buttons and then that creates your resource. We don't want that. We want you to create your resources using what's called infrastructure as code. And we're going to talk about this next week, and this is a big part of the DevOps process, where you will configure resources using code in a language called Terraform. If you haven't heard of it, Google it over the weekend. It's becoming more and more popular for resource configuration. It's a declarative framework that allows you to say, I want this number of lambdas and this number of APIs, and very useful and very powerful. You need to use Git. Who would have thought? So what we'll do is give you access to a GitHub space, which allows you to create a new repo, and everyone's going to be able to see everyone else's code because we're all one big company and you're all teams within that company, and each team has its own service, its own repository. That'll be useful as well when you're doing interoperability. You're able to see each other's interfaces and can understand how other teams are working a bit better. You need to write decent code. We're not going to mark this like super extensively because at this point we expect that you can write semi-decent code. But do make sure your code's not looking horrible is the main thing there. Continuous integration, DevOps, again, big emphasis, and CI is a part of it. You've been doing this since 1.5.3.1. We'll give you a repo which already has a pipeline set up in it, and that has actions to deploy the service into the environment. But then you'll also need to go and change some of that to include things like running your tests automatically, running your coverage checking, your linting, all the usual stuff. We also expect you to do some testing in Sprint 1. It doesn't have to be super extensive because Sprint 2 will be mainly, you'll have another team testing your service. But you should write unit tests and use test-driven development and make sure that your code is working and have that running in the CI. Git practices, again, we're not going to assess this, but make sure you write good commit messages, don't push your code straight to master, all that stuff that you know very well at this point. For those of you building a container microservice, you need to have a Docker file and deploy it in a container. There'll also be some assumptions you'll make, again, like most of the courses you've done or projects that are similar. Just chuck it in a Confluence page and again, show us that you've gone through that process. Jira task tracking, again, all the same as what you've done before. You'll be using the Jira board, make sure the boards show the truth, keep it up to date, and keep following it according to priority. Instructions for deploying a service into the ecosystem can be found on this page, insert page link. That'll be there eventually. So you get instructions on how to deploy and how to check that your service is working once deployed. So you're only in the dev environment, and then later we'll go to staging and production. And the last thing is, again, like the Shark Tanks, your demo or die presentation, where in week 5 you'll present essentially kind of like an oral version of your engineering proposal, where you say, this is our idea, this is the value we're adding, this is our architecture, and you'll demonstrate your deployed service in the ecosystem. This is a really common thing at tech companies where they do this sort of show and tell or showcase. We're calling it demo or die here because that's the traditional Scrum name, where you say, we have to have something to demonstrate or we're going to kill the project. That's where it comes from. So we expect that you do some practice and rehearsal for that. Get your public speaking skills up to scratch, because we'll be marking that. Later, I will put up some more detailed marking criteria. Just a bit of a busy week. And then this is all the stuff that's kind of admin-y. Email the class count for ELS and special consideration. Don't chat GPT. I don't know why you'd want to use it. And no play through them. Are there any questions? Yes.
You mentioned earlier that you might be working with other teams
Mm-hmm.
and you might take control like the it was the Apache Kafka event-driven communication stuff.
Yep.
Are we expected to build one microservice as part of like one project builder? Or are we meant to build a whole complete stack from microservices to
It's up to you. So you need to come up with it in your engineering proposal. It's mainly just like how much is you and your team willing to do in essentially. Well, it's essentially going to be 2 weeks, right? Because like week 1's almost done. It'll take you a week to plan your thing and do your proposal, and then you've got 2 weeks to build the service. So in that regard, it's up to you. And again, this is where you define your success criteria. This last section in terms of what we're marking you on, this section on software interoperability and cohesion is where we'll give you. It's not a huge amount, it's only 5%, but it's extra points for communicating with other teams, having interoperability, and making things work across teams. But if you want, you could build 10 microservices. You probably shouldn't do that because you only have 2 weeks, right? But it's all up to you in that regard.
Just generally, because you're part of the same company, we are the managers. We say, yeah, we give you to do one microservice, but then you can come back to us and say, actually, a bit more within this time because we believe that's on its own is not good. Because once you import data, you need other services to process the data. We haven't asked you to do that. That's the intention. Is over the years, people will build analysis service. But if some teams they have that capacity to do maybe a bit more than when we ask them, then there is rooms, flexibility. I think you can help the organization by having slightly different questions. Happy to do.
Yeah. Any other questions? No. All right, he's left. Great. Okay. Let's crack on with the next one.